Hello guys, welcome back to MedZone African Motives. Still working on our mathematics and 3 revisions. So this is November 2023 exam that we are going to be focusing with. That we just wrote recently. So we just want to see how exactly we're supposed to attempt these typical questions that we're given. So without wasting much of your time, guys, let us have our questions done. So we're given the first part of our question, which is question 1.1. It was to factorize as far as possible in prime factors. So you're supposed to factorize this in prime factors. Okay. If we were to consider this, it was just like a tricky question. But I want you to see something here. We're given P plus Qn into P minus Qn plus 2Qn minus 1 like this. Okay. If we are to consider this, it's something that we actually work with from our 2022 exams with something of this nature. But anyways, let's see. If we are to see, we are supposed to factorize, but we can consider that we do not have anything common in the first place, because if we had got something common, we're going to factor out that bracket, but we do not have as such. Okay, let us just expand the brackets for the meantime and see what's going to happen later on. Considering what we have here, we can see that this is a difference of 2 squares from the concept of a squared minus b squared. We know that this gives us a minus b into a plus b. So if you have to check, this is what we have, okay? Even though this one starts with a positive and a negative, that one is not a matter of fact, okay? What is important is that we have a p here. This is Qn, this is Qn. Separated, another bracket with a positive, another one with a minus. So meaning to say this before, we're going to square this, and we're also going to square this. We will square them, a squared minus b squared, okay? So meaning to say this, before it was going to be p squared minus, we squared this part, just like what we had with a and b. So it's going to be q squared n squared. All right, so this was our difference of 2 squares, this one. This was our difference of 2 squares that we had to expand, okay? If you have to factorize, it gives you these 2 brackets, but we still have these 2 terms, these other terms here, which is plus 2Qn minus 1 like this. Okay. Considering that what we have done is still like we are making things worse, but it's not like that. I want you to properly see what is happening with the last 3 terms with this trinomial that we are seeing here, this one. If we check properly these last 3 terms, it's a quadratic expression that we are used to, that we can even be able to factorize. But for us to be able to factorize properly, let us just make this to be a positive. So you can factor out a negative from that. So it's going to be p squared. We factor out -1. So if we factor out a -1, which is just a negative in that case, okay, we are going to have this negative and negative, which will be positive. So that will be q squared n squared, positive and negative, it will be negative 2Qn, negative and negative, that will be a positive 1 in this case. Okay, so like I said, this here is a quadratic expression that we are actually used to. All right, remember in our factorization, we are used to that type of a condition, this one that we are having here, this type here, okay, whereby I told you that if the coefficient of this part of the first term, the one that carries the exponent of 2, is a 1, we're just going to have 2 brackets in that case. So we're going to just have 2 brackets from our factorization, okay? So these are 2 brackets that you're gonna have. In this case, let us just do it this way to say that we're gonna have the 2 brackets from this factorization. But remember, there are already these brackets here that are going to be affected by the negative that is outside, which you say it is a -1. We just factor it as a negative, okay? So in order for you to have Qn squared, this question is just like we have got x squared minus 2x plus 1. So it's the same thing that you consider having two brackets and x, then you consider factors of one. So it is the same thing that we have. Here we've got q squared, n squared. So we are going to have qn, and here we are going to have qn. Then you focus with one, okay? We need factors of one, just like these factors of one, but these factors should give us a -2. So we need two numbers. If we multiply those numbers, we get a +1, but if we add the numbers, we get a -2. So definitely we have to consider 1 and 1, but in order for us to get a -2, it must be -1 and -1. -1 times -1, it's a +1. If we add these two, -1 plus -1, we get -1, -1, which is -2, which is this one. So meaning to say, we are going to have -1 here, -1 there, because we are having -1, -1, okay? Then from there, if we are to consider properly here, we can see that this is a product of two brackets which are the same. Whatever that we factored out is the same. We obtained two brackets that are the same. So it's just like a multiplying x times x, which I know that is going to be x squared. So it is the same case also, even if you're multiplying two brackets, you can write that as a squared. So that means this is going to be p squared minus these two brackets, which are the same. So I'm just going to write it as qn minus 1 squared, all right? So remember this, I said the same as like there's a -1 there, or you can just leave it like that, okay? Now, if we are to consider what we have again here, we are back to the format that we talked about before, the difference of two squares. I told you, whenever you can write anything in this format whereby you are having a difference of two squares, we are going to have the answers, which are the square roots of these brackets. So these are just the square roots, which is the square root of p squared, which is p, minus, we're going to have the square root of this, just removing the square that you're having. So we're going to have qn minus 1 like this for our difference of two squares, okay? Then we're going to have another bracket adding these squares. So we're going to have p plus qn minus 1 like this, okay? So that means we can even simplify inside of the bracket, because that will be a negative times qn, which is minus qn, minus and minus, which is a +1. This, okay? And move on to this bracket, it's a plus. So a plus does not affect anything. So this will remain as it is, qn and -1, okay? So this was the final answer that I was actually expecting you guys to have at the end, okay? If you were to factorize properly, this we're supposed to have two brackets of this nature. So that's the idea there. You were just supposed to play around. They just wanted to test you, your difference of two squares, if you still remember those things and so forth. All right, so that was 4 marks for that. All right, then 1.2, if we are to consider this part we are given on 1.2, that we have got to determine the value of a in that case, okay? So we're given to determine the value of a if f of x is equal to this expression that we are given. So we're given f of x in that case, and from there, it gives a remainder of 22. So take note, as we are told that it gives a remainder of 22 when divided by x minus a. All right. So this is it. All right, let us take our expression. Remember, I talked about this vector and remainder theorem. 1.2, we want to calculate the value of a, given that our f of x is equal to 2x cubed plus 4ax squared minus 3a squared x minus 2. That was our expression for f of x. So they are telling us here that it gives us a remainder of 22. The remainder, take note, when divided by x minus a. So we've got a remainder of 22. So that's our remainder. When divided by what? By x minus a. So if you divide by this x minus a, you get a remainder of what? Of 22. We are dividing by x minus a. All right, remember what I told you guys about factor and remainder theorem. There are only two things that you have to consider from this part that you are dividing. We are dividing by x minus a. So the part that you're dividing by x minus a does not stop us to have the value of x. So what you do is that you have to find the value of x by equating your x minus a to be equal to 0, whether it's a factor or whether it's a remainder. That it's an option for every part. Then you determine your x. So your x, in this case, if we transpose our negative a to the other side of the equation, it is going to be what? A positive a. So meaning to say x is equal to a. Maybe x is equal to 2, or x is equal to 3, or x is equal to 4, whatever that you're getting from there. That part, like I said, it is not an option to say you do it only when you're dealing with a remainder or a factor. It happens for everything, whether it's a remainder, whether it's a factor. But now, if they say you are having a remainder like what we're having here, there's a remainder of 22. What it means is that f of this a, which is the value of x that you're having here, should be equal to the remainder. All right, so let me write it down. For a remainder, it follows that f of this one, which is our a, should be equal to the remainder. If they said it's a factor means that there is no remainder in that case. If it was a factor, then it means f of a was supposed to be equal to 0 when it is a factor. But when you are given that there is a remainder, f of a, you equate to the remainder. These are the only two things that you to consider about this topic. Only two things that you have just need to know. All right, so if we say f of a, it means wherever there is x, we are going to substitute a. Wherever we see x, we are going to substitute what? A. So this one is going to be 2a to the exponent of 3. Then on this part, we are going to have plus 4a. This is x squared. That is, we're going to have this as a to the exponent of 2 minus 3a squared. X is represented with a. So in place of x, we're going to write a minus 2. This is equal to what? F of a. In place of x, we have substituted a. That is what f of a means. But we are saying the f of a must be equal to the remainder. What is our remainder? Our remainder is 22. So you're supposed to equate this to 22. By doing so, you can be able to calculate the value of a. How so? As you can see, this is just an equation in terms of a. So you can be able to simplify. That will be 2a cubed plus a and a. That's a and a squared. That's to the exponent of 3 minus this one also gives us 3a to the exponent of 3 minus 2 is equal to 22. So as you can see, these are like terms. They are to the exponent of what? To the exponent of 3, having the same base. So you're going to add the numbers, 2 plus 4, which is 6, then 6 minus 3, which is 3. So you're going to have 3a to the exponent of 3, okay? So that's 3a to the exponent of 3 minus 2 is equal to 22. So for us to find a, we can transpose for the meantime the negative 2 to the other side so that it can be a positive, and this will give us 3a cubed is equal to 22 plus 2, which is a 24. So find the value of a. Before, you can just divide by 3. So you can see here that we are multiplying. So you can divide by 3 both sides. That's a to the exponent of 3 will give us what? 8. Okay, so if a to the exponent of 3 is 8, what about the value of a? The a, to remove the cube, you introduce the cube root on both sides, or you introduce to the exponent of a third. Okay, so that's one and the same thing. So here you're going to have the value of a and the cube root of a of 8, which is a 2. So therefore, our a in this case was going to be what? Was going to be a 2 from the cube root of 8. So this is the value of a that satisfies this condition that we are given, that if x is equal to 2, therefore the remainder is going to be what? Is going to be 22 if you divide by x minus 2. So you just have to relate with the questions as they do repeat in another way. You just have to play around with the questions, know and understand like the difference that I gave you between a factor and a remainder. That is the only difference. If it is a remainder, f of a is equal to the remainder. If it is a factor, f of a should be equal to 0 from that part. All right, so that was our question 1.2, which was worth the 4 marks. All right, let's see 1.3, which is worth the 6 marks. Simplify the following. So this is an expression that we are supposed to simplify. on 1.3, having 6 marks in all. Okay, so let us just take our expression aside. All right, so the first thing that I always say that it is best for you to introduce the division, to introduce multiplication in place of what? The division. But the first part, all right, let us just have our question as it was a squared minus a minus 6 over a squared plus a minus 20 multiplied to 2a minus 8 over 2a minus 6. So this was one of the nicest questions that we had. It was an obvious question because all the factorizations that we had here, they were just direct factorizations. But what was important, like I always say, is that the first thing, before you do your factorization, because you might forget, I'm not saying to factorize first is wrong, but introduce your multiplication in place of what? The division, so that you know that everything is right under multiplication. Whatever that you're going to do, you know that you are not tempted to cancel with the division, okay? So let us introduce the multiplication. So this will be a squared minus a minus 6 over, so this whole part is over a squared plus a minus 20 multiplied to 2a minus 8 over 2a minus 6. So if we are to introduce a multiplication here where there's a division, what is going to happen? Remember, you interchange the fraction that follows after the sign, after the division, because this is the one that is following. So it is the one that you interchange. So meaning to say we're going to have a squared minus 25 on top. So you're going to have a squared minus 25 on top, everything over the denominator, which is a squared minus 3a minus 10, like this. Okay. Now that we have got everything under multiplication, we can now do our factorization, as we know that whatever that we're going to do now, it's under multiplication, and we can cancel anything as long the relationship follows that is between the numerator and what? The denominator. All right, so let's consider the first part that we are having, a squared minus a minus 6. If we are to consider here the coefficient of a squared, it's a 1. So like I said, this was a nice question because it was direct. Just consider having a and a. Then we have to consider the constant, which is negative 6. So what are the factors of negative 6? If we add them, we must get a negative 1. Two numbers, you multiply them, they give you a negative 6. But if you add these numbers, you must get a negative 1. So definitely that's negative 3 and 2. If we multiply this, we get negative 6. If we add these two, we get a negative 1. So that's negative 3 there plus 2. But remember, it's a trial and error. You can try as many numbers as you can, but I just hope this one was clear. The same thing here. This is 1. So we're just going to have a and a here. Then we move on to negative 20. So considering negative 20 and a positive 1. What are the factors of negative 20? But if we add them, they must give us a positive 1. So there we must think about 5 and 4. But in order for us to get a negative 1, this must be a negative 4, all right? 5 times negative 4, it's negative 20. 5 plus minus 4, it's a 1. So these are the two numbers that we're going to need, plus 5 and a minus 4. So that's a plus 5 there and a minus 4. All right, on 2a minus 8 here, 2a minus 8, 2 is common there, so you can just factor out to our highest common factor. 2a divided by 2, that's a, minus 8 divided by 2, that's a minus 4, all right? So this whole part is over. The same thing on 2a minus 6, 2 is common, we factor out 2, that will be 2a divided by 2, which is a, minus 6 divided by 2, which is minus 3. Then we multiply, we've got a difference of 2 squares. We talked about this before. This is a perfect square, a perfect square. So that was going to be square root of a squared, which is a, the square root of 25, which is 5. So that will be minus 5, and the other bracket will be a plus 5. All right. The same thing here, the coefficient of a squared is a 1. So you're just going to have two brackets, a and a there. Then consider the factors of negative 10, two numbers that we can multiply to get negative 10. But if we add these numbers, they give us a negative 3. Let's think of 5 and 2. But in order for us to have a negative 10, this can be a negative, okay? 5 and negative 2. If we add this, we get a 3. If we add this, we get a negative 3. So this is the one that we need, minus 5 and what? And 2. So there will be minus 5 plus 2. So now we can cancel, like I said, as long the relationship follows that is between what? The numerator and the denominator, you can be able to cancel. Like here, we have a minus 3. We've got a minus 3 in the numerator, a minus 3 in the denominator. A plus 2 here, you also have a plus 2, 2 and 2. All right, the a minus 4 and the a minus 4. The a plus 5 here and the a plus 5, the a minus 5 and the a minus 5. So as we can see, we have canceled out everything. That means we are just left with 1 over 1. And 1 over 1 gives us what? Gives us a 1. So this whole part was going to give us a 1, not a 0, but a 1, okay? So don't make a mistake to say that if you cancel everything, then you put a 0 there. When you cancel out everything, it means we are left with 1 over 1. And 1 over 1 is equal to what? Is equal to 1. Okay, so that was worthy 6 marks for this. And then 1.4, by completing the square. Okay, so for x, by completing the square. So this is the equation that you're given to solve by completing the square. So let us try to see how we're supposed to apply our completing the square. So that was 4x squared minus x minus 1 is equal to 0. Remember, completing the square states that whenever you're using this, the coefficient of x squared must be a 1. That one, it's a must that you're supposed to know. The coefficient of x squared of the first term must be a 1. So how can we do that? We simply divide by the coefficient, which is 4 by 4 by 4 by 4 each and every term. So if we are to divide by 4, what does it mean? It means we're going to cancel this part. That will be x squared. This one is same as minus 1 over 4x. So it's same as with minus 1 over 4x minus 1 over 4 equal to 0 divided by 4. That's a 0, okay? So remember your stages. By completing the square, we are going to transpose the constant to the other side of the equation before you complete the square. So that will be x squared minus half 1 over 4x, which will be minus 1 over 4 to the other side will be a positive 1 over 4. So the idea here of completing the square is that we are supposed to determine half of the coefficient of x. We are talking about this, the coefficient of x, which is the minus 1 over 6, minus 1 over 4, this one. We are supposed to determine the square of this half. So we need to determine the square of this half of the coefficient of x, which is negative 1 over 4 like this. But we are supposed to determine its square, okay? And that square, you add it both sides. That is to complete a square. You are supposed to find half the coefficient of x, you square it, and you multiply or you add it both sides, all right? But for the purpose of what is going to follow, because of the factorization that is going to follow, I always advise that you do not simplify this like to get the exact value. Yes, you can just multiply these two inside. If you multiply this on your calculator, you get negative 1 over 8 to the exponent of 2. Just leave the exponent of 2. Don't simplify it. Yes, you can simplify it, but as long as you understand what you're doing. But I always tell you guys to avoid that. Okay, this is the reason. I want you to see why I'm saying you must avoid that. Because this is your square. You are supposed to add this square, both sides of the equation. So you're supposed to have x squared minus 1 over 4 plus the square, this one, the minus 1 over 8 squared, which is equal to 1 over 4 plus minus 1 over 8 squared. The square that we got here should be added both sides. And once you added both sides, this is what you can see. You can see that we now have a quadratic expression here on the left-hand side that is supposed to be factorized, and it's actually a perfect square expression that you're talking about. What am I trying to say if I'm saying it's a perfect square? I'm trying to say if you factorize it, you're supposed to have two brackets of the same, two brackets that are the same. And how do you obtain these brackets? I said you focus on the first term, the one that is being raised to the exponent of what? Of 2. And the last term that is being raised to the exponent of 2. So that you can, so the reason that I was saying, do not simplify, so that you can properly see the number that is being raised to the exponent of 2. Because most of you tend to take that number wrongly. So here you are going to take this number, which is minus 1/8, and here it's x. So we take the first and the last term together, okay? So the first term, which is x, and this one on the last term, which is minus 1/8. This is how you factorize this, minus 1/8, everything to the exponent of 2. You have factorized this whole part, okay? Then you simplify the other side. So if you check the other videos on completing the square, I've explained a lot about this, how and what does it actually mean on this factorization. But in short, this is how you do your factorization, okay? Then on the right-hand side, you are doing nothing, just to simplify 1/4. There's no factorization here, just simplify negative 1/4 plus, open bracket, that's negative 1/8 to the exponent of 2. So this will give us 17/8, okay? So you're gonna have 17 over, is it 8 or 60? 17/64 there. So this is 17/64 like this, okay? So how can we solve for x now? As you can see, we've got the square on this side, and we talked about removing the square by introducing the square root. So this will be the square root this side, the square root this side, and we remain with x minus 1/8, which is equal to, knowing that the square root of any number is a plus or minus. So whatever that you're going to determine here is going to be a plus or minus. So you can leave it like that, or you can determine the square root. You have your calculator here, so you can even determine the square root of that, because we've got 17/64, and its square root, that is the square root of the answer, is going to be the square root of 17/8. We can't determine the square root of 17, so it will be the square root of 17/8 like this. So as we can see, we can actually determine our x by transposing the negative 1/8 to the right-hand side, so that it becomes what? It becomes a positive. So that is going to be positive 1/8 plus or minus the square root of 17/8. So from here, we can have two solutions if we consider that there is a plus and there's also a minus. So we can combine this whole thing together. That is 1/8. So you're gonna have, let's start with the plus, 1/8 like this, plus the square root of 17/8, okay? So you're gonna have the square root of 17, in this case, everything over 8. All right, so this is going to give us 0.640 like that. So that is the instruction of this question paper was actually to 3 decimal place, and you can round off direct to 3 decimal place on your calculator by just doing this shift. You go to the setup, all right, then fix on number 6. You're gonna fix your calculator to 3 decimal place. You press the 3. That will be your answer is going to be to 3 decimal places, which is 0.640, 0.640. So this is the value of x that you're gonna have for a positive, or we are going to have our x when this is a negative here. So we're just gonna put a negative here on this part. Let's remove this and put a negative there. So this is going to give us negative 0.390. That's negative 0.390 to 3 decimal places as per instruction of your question paper. Unless stated otherwise, you can use the decimal places that are being given for that particular question. Besides, you use the decimal place that are being given from the instruction of the question paper, and this was to be supposed to be given to what? To 3 decimal places. Okay. So that is it by completing the square. And as you can see, this is a normal quadratic equation that you are used to. So you were also supposed to prove your answers by using the quadratic formula under exam condition. It's true that you are told to use a certain method, but for proof, you can use the method that you are used to, and you guys, you are used to the quadratic formula. Use that quadratic formula to prove your answers, all right? Then in case of being limited to the last extent, if you're in exam, and you do not understand the method that you're given there, use the other method. You are not going to be awarded the marks for the method, but you'll be given the marks for other steps. Okay, that for the method that you are using, they won't give you full marks because there's supposed to be a mark that is awarded for the method that is supposed to be used when given a certain method. So that was question 1. Question 2. Simplify the following expression. So that's the expression that we're given to simplify 20 to the exponent of 2n plus 1 multiplied by 100 to the exponent of 2 minus n divided by this 64 to the exponent of n over 3, 4 marks. Okay, let us just see how we're supposed to have this question. If you are to consider properly, I want us to have our question properly if we are to consider this. All right, so this is question 2.1, which is our question 2. So that was 20 to the exponent of 2n to the exponent of 2n plus 1. And this is being multiplied to 100 to the exponent of 2 minus n. So that is 2 minus n, and divided by 64 to the exponent of n over 3. If we are to consider such type of simplification, where the bases, they are totally different, there is 20, there is 100, there is 64. In cases like these, simplify your numbers as product of their prime factors. Okay, let's first consider the division. As we know that always when you've got a division, write it in a way that you understand it. So this here is the same as we've got 20 to the exponent of 2n plus 1 multiplied to 100 to the exponent of 2 minus n. Everything like this is being affected by what? Everything is being affected by 64 to the exponent of n over 3. Remember that if you multiply like 2 over 3, multiply it to 4, it means we've got over 1. So you're going to multiply 2 times this times this. So it means this whole part is affected, this whole part is affected. So this, yes, it's true that it was just affecting this like this. But the moment you write it over, it is now affecting everything, okay? So that is the concept of a division. Do not worry about that. So like I said, when the bases are so different that we can't even write in the same base, there's no way we can write 120 and 64 in the same base. It's impossible. So what we can do is to write these numbers as a product of their prime factors. What am I trying to say? 20 as a product of its prime factors, we said we divide by the smallest number, which is 2. 2 into 20, that is a 10. We divide by 2. 20 divided by 2, that's a 5. Now we can use 5. 5 divided by 5, which is 1. So it means this 20 that we see, it is the same as 2 times 2 times 5. From our mathematics N1, we talked about this. So that means this 20 is equal to 2 times 2, which is 2 squared, times what? Times 5. So whenever we are seeing this 20, we are seeing 2 squared times 5 in the simplest form. When I'm saying as a product of its prime factors, it's because our answers, they are supposed to be in what? In the simplest form. So you're supposed to choose prime numbers, not to say 4 times 5. You're supposed to use the smallest number, which is 2, that the prime numbers, okay? So 20 is same as 2 to the exponent of 2 multiplied by what? Multiplied by 5. This is the 20 that we see. But the 20 that we see here is being raised to the exponent of what? Of 2n plus 1. So you're not supposed to forget the exponent of 2n plus 1. Okay. What we have done on 20 is the same thing that we are going to do on 100 as a product of its prime factor. So this is our 100. The smallest number there, the prime number is 2. 100 divided by 2, that will be a 50. The smallest again is 2. 50 divided by 2, which is 25. The smallest prime factor now is 5. 25 divided by 5, which is 5. 5 and 5, which is 1. So 100 is same as 2 times 2 times 5 times 5, which is the same as 2 times 2, that is 2 to the exponent of 2. 2 times 2, that is 2 to the exponent of 2. 5 times 5, which that is what? 5 to the exponent of 2. All right. So meaning to say, wherever I'm seeing this 100 here, I'm seeing 2 to the exponent of 2 times 5 to the exponent of 2. This is what I'm seeing in its simplest form. So this here, we can write it as times 100, which is 2 to the exponent of 2 times 5 to the exponent of 2. But everything on that, because it's 100, is being affected by what? By 2 minus n on the exponent. All right. So this whole part is going to also affect this. All right. Remember, you've got 64. So this, everything over. As for 64, there is no need for us to write 64 as a product of its prime factors. Yes, we can that 2, 2, and so forth. But 64, we know that it can be written as a number in the same, in one base, which is the base of 2. 64, that's 2 to the exponent of 6. All right, you can also try that on your calculator, and being raised to the exponent of what? Of 3. But like I said, you can also do the same. 64, the smallest number is 2. 64 by 2, which is 32. The smallest number, 2. 16, the smallest number, which is 8 by 2, which is 4. The smallest number, which is 2 by 2, 2, 1. So as you can see, I've got 1, 2, 3, 4, 5, 6. So that's 2 to the exponent of what? 2 to the exponent of a 6 in that manner. Okay. Now that we have written our numbers as prime factors in simplest form, or because prime numbers are always the simplest numbers, or they're always in simplest form. But there are laws that are there that need to be considered, because now you can see that the bracket that we have here is being raised to the exponent of 2n plus 1. And as we understand that whatever that we're going to have in a bracket and raised to a certain exponent, which is m, it means everything is going to be raised to the same exponent. That is going to be a is going to be raised to the exponent of m, b also to the exponent. Everything is going to be raised by the exponent. So here it means that if we had to apply that, the 2 to the exponent of 2, this one was going to be raised to the exponent of 2n. The 5 also, the same thing here, the same thing. Everything that we have must be raised to the exponent. That is what? That is outside. Okay, so let us start with 2 to the exponent of 2. So it was supposed to be like this. 2 to the exponent of 2. This is what we're supposed to have. But also to the exponent of 2n, because there's an exponent outside, which is 2n plus 1. So what is going to happen? Exponent and exponent multiplies each other. So this will be 2 to the exponent of 2 times 2, which is 4n, 2 times 1, which is a 2. So that will be 2 to the exponent of 4n plus 2. The 5 is same as 1. So it's just going to multiply 1 times this. So this 5 is just going to remain as it is. So that will be by 5 to the exponent of 2n plus 1. Okay. Let's move on to this one here. Also the same thing. This 2 to the exponent of 2 raised to the exponent of 2n minus 1. So it was supposed to be like this. It was supposed to be written as, okay, 2 to the exponent of 2. Being raised to the exponent of 2 minus n. There's an exponent and there's also an exponent. So this multiplies. 2 distributes everything. So that is going to be times 2 to the exponent of 2 times 2, which is 4, 2 times negative 2, 2 times negative n, which is negative 2n. We do the same thing on the 5, but as you can see, it's the same exponent of 2. So meaning to say this 5 here was going to be 5 to the exponent of 2 times 2, which is 4, 2 times minus n, which is minus 2n, just like what we did on this 2, but it will be just 5 to the exponent of what? 5 to the exponent of 2. All right, in the denominator, we still have the same thing, but here, I've got 2 to the exponent of 6 raised to the exponent of n over 3. The idea is still the same. We're going to multiply 6 times n over 3 like this. So this is what can happen. 3 when divided by 6 gives us a 2. 6 divided by 3, 6 divided by 3, that's a 2. So 2 times n, which is 2n. So this would be 2 to the exponent of what? Of 2n. So this whole part was going to be divided, all this that we see, by 2 to the exponent of 2n. Okay. Now that we are seeing this, at least we have got an idea of where this now goes, because we can see that the base that we are talking about are the same, can be simplified, and we've got the base of 2 and also the base of 5. So considering the base of 2 on top, because we know that whenever we are multiplying, we add the exponents. So these on top, they are multiplying. We are going to add their exponents. 2 to the exponent of 4n plus 2. We add the exponent here on 2, which is plus 4 minus 2n. But there is another 2 here that is in the denominator, this one, which is dividing, because everything now is dividing. So what do we do if we are dividing? We subtract the exponent. So we are going to subtract 2n. All right, let's go on to 5. 5 on top is multiplying this one and this one, they are multiplying. So we're going to add their exponents. So it's 5 to the exponent of 2n plus 1 plus this exponent here, which is 4 minus 2n. So this is what we're going to have at the end. And as you can see, you can be able to simplify by collecting the like terms. Here we've got 4n minus 2n. That one was going to give us a 0. So we're just left with the numbers 2 plus 4, which is a 6. So that was going to be 2 to the exponent of 6 multiplied to 5 to the exponent of 2n minus 2n. That's a 0. So you're going to add the numbers 1 plus 4, which is a 5. So that's 5 to the exponent of 5. So you can simplify this direct on your calculator. You can just simplify this direct on your calculator. So this is what you're going to have. Remember, our calculator is being fixed here to 3 decimal places. So let us just go back to the normal mode. So it's shift, set up, we go to the normal on 8, then press 2, it is now in the normal mode, okay? So you can just simplify 2 to the exponent of 6, all right? So this is 2 to the exponent of a 6, all right? So this calculator is a little bit delaying. So let's see 2 to the exponent of 6 like this, which is something like 64, all right? So we are going to obtain 64 multiplied to 5 to the exponent of a 5. So that's 5 to the exponent of a 5, which is 3,125. So you're going to just combine this whole thing here times the 64 that we got previously. This will give us 200,000. There are 5 zeros there. So it means we've got 200,000 at the end. So this is 200,000, or you can just write as 2 times 10 to the exponent of 5. 2 times 10 to the exponent of what? Of 5, since we've got 5 in that case, or just leave it like that as a 200,000. So these are the typical questions that they are asking you guys, because they are testing you on the understanding of working with the different bases, because they know that if they just give you a single base that you are used to, you are going to simplify that. So now they want you to know a relationship when the bases are. All right, so let's check, let's just try to check out the next part, which is 2.2. So this one was an equation, a logarithmic equation. We're asked to solve for x in that manner. Okay, so let us see how were we supposed to solve for x on this logarithm, and that was 5 marks for everything there. All right, so let's see. The logarithm of x squared minus 5 is equal to log 10x. All right, so that's 2.21. Okay, so this is 2.21. We are given the logarithm of x squared, okay, minus 5, which is equal to the logarithm of 10x. Whenever you are working with the logarithms, whether it is to solve an equation, whether you're solving an equation, you're dealing with the logarithms, you're supposed to understand that everything about the logarithms goes about the laws. So the first thing that we're just supposed to ask ourselves is that what exactly made us to multiply 10 and x here? Because this is 10x. 10x means 10 times x. It simply means that we were adding the logarithms. Remember, the logarithm of AB was being taken from the logarithm of A plus the logarithm of B, provided that we have got the same basis, all right? And in this case, if the base is not written, it means we are in base of 10, right? So that means what made us to multiply these two, like AB, we were adding log A and log B. So that is the same case that you're going to write this. It's going to be log x to the exponent of 2 minus 5, which is equal to the logarithm of 10 plus the logarithm of x. So take note, we had log 10 plus log x, and we multiplied 10 times x because the bases are the same. Like I said, if the base is not given like this, it means we are in base of what? We are in base of 10. And in base of 10, we know that the logarithm of 10 in base of 10 is equal to 1. Or we can take that the logarithm of A in base of A is equal to 1. So this here is a 1. So that means we can even transpose our terms to the other side of the equation. This would be log x squared. If we take this log x base 10 this side, it is going to be a negative. It was a positive, so it is going to be a negative. So that's the logarithm of x in base of 10. Already here, there was a minus 5, and we are now taking the 1. Remember, we said log 10 base 10 is a 1. So if we take this 1, the other side, it becomes a negative 1. So that's negative 1 is equal to 0. So as we can see, this is a quadratic, a normal quadratic equation that we are simply seeing here, but only that it is in a log form. We are having a quadratic equation. Let's see, because we're going to have logarithm of x in base of 10 squared minus the logarithm of x in base of 10 minus 5 minus 1, that's minus 6, which is equal to 0. This is not just a normal equation, it's just a quadratic that we are used to. Even though it's given in a log, but it's just a quadratic. Okay, remember your quadratic equation, ax squared plus bx plus c is equal to 0. This is what we have. This one raised to the exponent of 2, and we've got log of x and so forth. So if you understand that, you can even factorize. Yes, you can introduce the k. I'm going to explain that one later on. But if you understand this and see that it's a quadratic equation, you can factorize because you see that the coefficient of this x squared, like the first term is a 1. So it means we are going to have 2 brackets in that case. If this was x, you're going to write x and x, but this is not x. This is log x base 10, log x base 10. So this is going to be log x base 10 here, also log x base 10. So that if you multiply log x base 10, log base 10, it gives us log x base 10 squared. All right, remember, how do you simplify? We talked about this on question number 1 on those factorizations and so forth. We said we focus with a constant, all right, -6. Factors of -6 that we are going to add them, they give us a -1. And I think we talked about the factors of -6 before. We said we've got -3 and 2. If we multiply this, we get a -6. If we add, we get a -1. So this will be a -3, a +2, which is equal to 0. So that is how you can actually factorize direct, or you can introduce the k. Like I said, I'm going to talk about that. But from this case, from the 0 concept, we all understand that whenever 2 brackets are equated to 0 like this, it means one of these brackets must be equal to 0. So it means it's either the logarithm of x in base of 10 minus 3 must be equal to 0, or the logarithm of x in base of 10 plus 2 must be equal to 0. So from there, we can be able to calculate the value of x. All right, so let's transpose first the numbers to the other side of our equation. So that means we are going to be left with the logarithm of x in base of 10 equal to 3, or here you are going to be left with the logarithm of x in base of 10. If you transpose 2 to that side, it becomes a -2. remembering that from our logarithms, remember it follows that if I am given the logarithm of A in base of B is equal to C, it follows that this A here is equal to the base to the exponent of, which is B to the exponent of what? C in exponential form. So we can do that to say we can find the X if we consider this to say A is equal to base to the base to the exponent of the answer, whereby what is representing this A in this case is our X, okay? So it means our X will be equal to the base, which is 10 to the exponent of 3. So this will be 10 to the exponent of 3. So that's 10 to the exponent of 3. Or we do the same thing, the X here must be equal to the base to the exponent of the answer, which is 10 to the exponent of -2. Once you're at that stage, you can even use a calculator if you want 10 to the exponent of 3, which is 1,000, or X is going to be 10 to the exponent of -2, which is 1 over 10 to the exponent of 2, which is 1 over 100. So these are the X values that we are expecting to have from this logarithm that we are given. All right, so that is how we were supposed to evaluate, to solve this equation. It's a logarithmic equation, yes, but as we saw that at the end, we ended up having a quadratic equation. All right, we ended up having a quadratic equation that we can solve by factorizing, and we can find our values of X later on by applying the relationship that we have between the logarithms and the exponents, okay? So like I said, on this equation, someone could have taken it that way from this equation here, from this part here. All right, instead, because maybe you are not understanding working with the logarithm, so you can even introduce, when you are at that stage, you can even introduce K in that case. You can just say, let K be equal to, or in this case, you can just write as the logarithm, whatever way that you understand, okay? Or you can just write as K, or you can write the logarithm of X in base of 10 be equal to K. What does that part mean? It means wherever I see the logarithm of X in base of 10, I'm going to substitute with K. So here I've got the logarithm of X in base of 10, but it is being squared. So that is going to be K squared, okay? Minus log X base 10. So this is minus K. Remember, log X base 10 is K. Minus 6, there is no log here, so it's just going to remain as it is. Minus 6 is equal to 0. So as you can see, it's a normal quadratic equation that we are used to. So you can solve this with whatever way that you understand. But as you can see, you're gonna just go back to the factorization K and K, focus with the -6 and -1. We said this will be -3 and a +2. So meaning to say, if we transpose 3 to the other side, it becomes a positive. So K is going to be 3, or we are going to have K as transpose 2 to the other side, it becomes a -2. These are the values of K, not X. Our equation was not about K. We introduced this K. It is us who introduced this K. So at the end, if you were to opt using this, you must remember to take back this now. You must remember to go back to the stage where you introduced your logarithm to say the logarithm of X in base of 10 is equal to K, and your K is 3. Or the logarithm of X in base of 10 is equal to K, and the other K that we got here is a -2. So as you can see, we are back to this stage here that we talked about previously here, where we have got the logarithm of X in base of 10 equal to 3, which is the same as this and this one here. So the later stage is just going to be the same throughout up to the final answer. All right, so this is just another alternative, like if you choose to introduce K, but you could have just factorized direct, then we solve our equation, just like a normal quadratic equation, because this is an equation, only that it is under logarithms, but it's a quadratic equation. So it can also use the same concept, just like our logarithms, all right? Then on 2.22, we are now given to solve again for x. So we're still solving for x, and this is actually 5 marks for that. Okay, so let's see our equation that we're given here. All right, 5 marks for that. So this was given as 2.23. All right, so this is 2.23. So we are given in this case that is 3 into x to the exponent of a half plus x to the exponent of minus half, which is equal to 10. So on this one, I think there are so many ways that you can actually use to solve this equation. If you want, maybe you are confused because of this 3, you can remove this 3 because it's multiplying. You can just divide by 3, both sides, just divide by 3 so that you can properly work with what you understand. This is x to the exponent of a half plus x to the exponent of minus half, which is equal to 10 over 3. All right, what is it that we understand? We understand that to the exponent of a negative means 1 over. So to remove a negative exponent, we are going to remove this negative by introducing 1 over. That is what we understand from our exponents. So this will be x to the exponent of a half plus, to remove the negative exponent, as I'm explaining, it's going to be 1 over x to the exponent of a half, which is equal to 10 over 3. So as you can see on the left-hand side, there's something that is common that we can consider. Or we can just clear the fractions because now this is same as over 1. And we've got the fractions, we've got 1, we've got x to the exponent of a half, we've got a 3. So our LCD is going to be everything that we have, which is our LCD. In this case, is going to be 3 in place of the numbers. Then we've got x to the exponent of a half, which is our LCM or the LCD, okay? So meaning to say each term we are going to multiply by the LCD, which is 3x to the exponent of a half. To clear the fractions, we multiply also here 3x to the exponent of a half. We also multiply here 3x to the exponent of a half. This is to clear what? The fractions. You multiply every term by the LCD. So by doing this, we are going to see that if we multiply here, 3x to the exponent of a half is going to multiply another x to the exponent of a half. So it's same as x times x, which is x squared. So x to the exponent of a half times x to the exponent of a half. I know that this one is going to give us x because we add the half plus half, which is a 1, which is same as x. But just avoid that because there's also another x to the exponent of a half. So just leave it like that. Write it in terms of x to the exponent of a half to say that we are multiplying the same thing. So this can be written as 3x to the exponent of a half like this to the exponent of 2. Okay? Write it in a way that you understand. Okay? Then on this part, we can cancel because these are the same. So this can cancel, meaning to say we are left with 1 times 3, which is a 3. So that's plus 3. The 3 and the 3 cancels here. That's going to be 10 times x to the exponent of a half, which is 10x to the exponent of a half. So as you can see, we are now having another disguised quadratic equation, just like the previous case of that logarithm. Because the moment we take this to the other side of our equation, this will be 3 into x to the exponent of a half to the exponent of a 2 like this, minus, you take this to the other side, it becomes a minus 10 x to the exponent of a half plus 3 is equal to 0. So you can try your factorization, which is actually one and the same thing, which is actually fine. But in this case, working with the x to the exponent of half, you can see that maybe some of us might have a little bit confusion. And also that this time it's not a direct factorization like the previous case. So we can also do the same thing like previous case where I said you can introduce k. So you can say let x to the exponent of a half be equal to what? Be equal to k. So it means here I'm going to have a k to the exponent of 2, all right? Then this one is just a k. Wherever there is x to the exponent of a half, I'm going to replace with what? With k. So like I said, this will be 3 k to the exponent of 2 minus 10k plus 3, which is equal to 0. So as you can see, this is a normal quadratic equation that we are used to and we can solve that quadratic equation either by factorization, by quadratic formula, whatever that you are used to. If we are to consider the formula, it was that k was going to be equal to negative b, which is our negative. Okay, remember the formula negative b plus or minus the square root of b squared minus 4ac all over what? All over 2a. All right, so that means we can be able to simplify. Even by factorization, I think here we're going to have factors, but still we have already written the formula. So that's negative b, which is negative b, our b, there's 10. Remember, this is our a, our b, and our c. So you're going to have negative b, which is negative 10, plus or minus the square root of b squared, which is negative 10 squared. So that's negative 10 squared minus 4 times a, which is 3, times c, which is also a 3. Okay, so that is it. Everything over 2 times a, our a, which is a 3 in that case. Okay, so this is giving us the value of k, not the value of x. Remember that. So k is going to be negative here. That's a positive 10. Plus or minus, you can just simplify the square root at once. I think this one is just going to be direct. Minus 10 squared. Okay, let me just, but it's the same. Minus 10 squared minus 4 times 3. So you're going to subtract minus 4 times 3 times 3. Okay, times 3 again. Okay. Just hope this one is a little bit slow. It's not going to take everything. That's 64. So you're going to have the square root. All right. That will be a square root of 64. Let me show the screen, guys. I forgot to show the screen there. So this will be a 64 like this. Okay. You simplify this. So that will be the square root of 64 over 2 times 3, which is a 6. All right. So at this stage, you can just determine your case separately. On your calculator, just save a fraction here. That's 10 plus the square root of 64. All right, plus the square root of 64. Everything over 6, which is 2 times 3, which gave us a 6. That's k is going to be equal to 3. Or we have to simplify the other part of k by introducing a negative here on top. So let's just move this until we can be able to delete. All right, this is affected. I don't know why this is so slow like this, guys, but let's just stop. We're gonna be able to win up the wallpaper here. All right, something like this. So that was going to give us 1 over 3. So the k there is going to be 1 over 3. All right, so with the value of k that we have here, what are we going to do? We are now going back to the introduction, because the k, we are not solving for k. This equation is not for k. This equation is for x. So we have to get back here where we introduced our k. So whether you use the factorization method, whatever method that you used to solve here, you are supposed to go back and what? Substitute back here. We said let x to the exponent of a half be equal to k. Meaning to say, where we have x to the exponent of half, we're going to equate to the values of k that we got here. So x to the exponent of a half, remember it is equal to what? To k. But the first k that we got here is a 3, or we're going to have another expression, another equation for x to the exponent of a half being equal to the value of k that we got on the other side, which is 1 over 3. So the question is, how do we get the value of what? The value of x in that case. How are we going to obtain x? If raised to the exponent of a fraction, you find the reciprocal of the fraction. The reciprocal or the inverse means 1 over that fraction. The exponent, as long as you're given an exponent, you find the reciprocal. So the reciprocal of this is 1 over 2. So you're going to have 1 over 2. That is the reciprocal of 1 over 2, means 1 over 1 over 2. So the reciprocal of this is going to be equal to 2. If you simplify properly, we are going to obtain our reciprocal, which is what? Which is 2. Why are we finding the reciprocal? This reciprocal or the inverse, you raise it to each term. You're going to raise this to the exponent of the reciprocal. to the exponent of the reciprocal, which is our inverse, the same thing, because it's the same exponent of half, you do the same thing here. By doing so, we are having the exact value of x, because a half times a 2, it gives us a 1. And x to the exponent of 1 is same as what? Is same as x, which is equal to 3 to the exponent of 2, which is 9. That's 3 times 3. All right, the same thing here, a half and a 2, that gives us an x, because we're going to have x to the exponent of a 1, which is same as x. 1 over 3 to the exponent of 2, that will give you 1 over 9. So now we have got the exact values of what? The exact values of what? Of x. So this is how we're supposed to solve our equation in that manner. All right, so you can even test our values if they do match what is on the right hand side and what is on the left hand side. But as you can see, we can have a lot of stages, a lot of ways of finding this, but at the end we must have the same quadratic equation. This one here, we must have the same equation on this quadratic. All right, let us see the other part. So that was question 2. Then question 3, we are now given here, make A the subject of the formula. All right, so this is not complete. Let me just rewrite this question the way that it is from the question paper that I'm having here. All right, so we are being asked, yes, to make A the subject or to solve for A in that case. All right, so this is 3.1. So we are given B A squared. This was the question, B A squared plus DA is equal to V. This was the question. Okay, you wanted to say, what type of a question is this? When you're asked to make A the subject, you are actually solving for A. The question here is make A the subject of the formula. You are solving for A. So to solve for A, it's either you're going to work it by completing of the square method, or you're going to use the quadratic formula, because A is raised to the exponent of 2. And as you can see, there's another A here, and we can't make A the subject because this one is being raised to the exponent of 2. But this one is not raised to the exponent of 2, it's the exponent of 1. So what we can see is that this is just a normal quadratic equation that we are given. So if we transpose this, this will be minus V is equal to 0. So we are having a quadratic equation, just like all the quadratic equations that we had before, solving for log, solving for this, but now we are solving for A. So like I said, you can also do it by completing the square, but using your quadratic formula, it states that A is equal to minus B plus or minus the square root of B squared. Remember your formula, B squared minus 4AC all over 2A. So what is representing our B, our A, and so forth? So we are talking about A, just like where there is A, it's just like there is X squared and X. So it means from the format that we know, AX squared plus BX plus C is equal to 0. A is the coefficient of X squared. So meaning to say our A squared, okay, this one, A squared is same as X squared. So this is our A, which is our B, this one. Our B, which is this B of the formula, is this D, this one, all right, which is plus D. Our C, which is the constant, which is going to be what? Minus V. So you can substitute to say A, which is just like X is equal to, we are solving for A, is going to be equal to minus B, whereby our B is D in this case. So it's minus D plus or minus the square root of B squared, whereby B is D. So this is going to be D squared minus 4 times A. Our A, remember, we said it's B times C, and C is negative V. So this is a negative V like this, okay? Everything over 2A, which is 2 times our A, remember it's B. So it's everything over 2B like this, okay? So if we are to consider that, we can see that, you can clearly see that here we can simplify, all right? We can simplify what is inside of the bracket. So A was going to be equal to minus D plus or minus, we simplify a negative and a negative there, it gives us a positive. So this will be the square root of d squared minus minus, like I said, is going to be a positive. So you're going to multiply 4 times b times v, which is 4bv, like this. Everything over 2 times b, which is 2b. So that's it. We have made a to be the subject of the formula, which we can also separate if you want, or you can just leave it like that. So like I said, this also could have done by completing of the square method. How? By completing of the square method. All right, so let us see. We want to make a the subject, remember? So you're just gonna solve. So at this stage, we are going to just even start there at this stage here. Remember, completing of the square, we can start from here. From our completing of the square method, remember what we want is to make x squared, the coefficient of x squared, to be 1. But here we're talking about the coefficient of a squared, not x squared, but a squared. So for this to be 1, we have to divide by b here, by b this side. So this is going to be a squared plus d over b times a. All right, because remember, a is representing just like x. A is our x, okay, which is equal to v over b. Let's consider our completing of the square method the way that we used it on that question. We said what we are going to need is half the coefficient of x. But remember, what is representing x in this question is a squared, x, okay? So we're going to need half the coefficient of a in this case, right? So on this side, we are going to need half the coefficient, which is the term that is affecting a, which is d over b. What do we do with this half? We are supposed to square it. So this is 1 times d, which is d, over 2 times b, which is 2b. Everything raised to the exponent of 2. And like I said, do not simplify the square. Just leave it like that. Yes, you can simplify if you want, but just leave it like that so that you properly understand exactly what you're talking about at the end. So this is our square that we are going to add both sides of the equation. So we're going to have a squared plus d over ba plus this square, which is d over 2b to the exponent of 2, which is equal to, on the other hand, we do the same thing, v over b, we add our square, which is going to be d over 2b to the exponent of 2. So like I said from the previous case, on the left-hand side, you are supposed to factorize because you now have a quadratic expression here. This is a quadratic expression. In fact, a perfect square. And I told you to factorize, you're just going to take the first term, the one raised to the exponent of 2, and the last term also raised to the exponent of 2. So this is going to be a plus d over 2b, like this, everything to the exponent of 2. That's how you factorize it, okay? The right-hand side, you simplify properly. So this is going to be, let us just simplify this aside and see what we're going to have, guys, aside here. If we square this, all right, let's take this as it is, v over b plus, let's square this, d squared, that's d to the exponent, which is d squared over 2 squared, which is 4 b squared. So remember there we are supposed to consider the LCM so that we add, which is 4b squared. So it's 4b squared divided by b, which is 4b, times this v, so it's going to be 4bv plus 4b squared divided by 4b squared, which is 1, then 1 times d squared, which is d squared. So as we can see, this is the same way that we wrote last time as d squared plus 4bv. So it's just the one and the same thing, all right? So that is the one that we are getting here. If we add, we are going to obtain 4bv plus d squared over 4b squared. So by our completing of the square method, we can introduce the square root both sides. So we're going to have the square root here and also the square root there. So that is going to give us now the exact part that we want. Remember how we applied our completing of the square method last time. So this removes the square. So it's going to be a plus d over 2b, which is equal to, this time, just like the previous part, if you still remember, that was 17 over 64. When we determine the square root, we couldn't manage to determine the square root of 17, but we determined the square root of 64, and that gave us square root of 17 over 8, if you still remember that question. It is the same thing that is happening. We can't determine the square root of what is in the numerator. It's an expression. It's a combination of terms that we are talking about there. They are combined. It's an expression. We can't determine its square root. But we can determine the square root of 4b squared. The square root of 4 is 2. The square root of b squared is b. It's a single term. But this one is an expression. So we can't determine its square root. So it is just going to remain as it is, but knowing that the square root of n number is plus or minus. So it's going to be plus or minus the square root of 4bv plus d squared, everything over. Now, like I said, we can determine the square root of 4b squared because it's a single term. The square root of 4, which is 2, the square root of b squared, which is a b. So how are we going to solve for a in that case? We are going to transpose this to the other side. It becomes a negative there. So meaning to say a is going to be equal to minus d over 2b plus or minus the square root of this part, which is 4bv plus d squared. Everything that we have here is over what? Over 2b. Remember what I said about the fractions, that if the denominators are the same, you just combine the numerators together, okay? We understand that if I'm given a over b plus c over b, because these denominators are the same, I just combine the numerators together, a plus c, everything over b. So it is the same thing. I've got 2b, I've got 2b. So I'm going to combine everything. So a is going to be equal to minus d plus or minus the square root of 4bv plus d squared, everything now over what? Everything over 2b. So we can make a to be the subject that we're considering what? Completing of the square method. So guys, there are different ways, as we can see, of solving these typical questions. All you just need is to make sure that you work with many questions, understand the concept of the question. The concept of the question is the major part that you're supposed to understand. What is the question asking you to do, and how are you supposed to attempt that? Okay, so that was 3.1 on question number 3. Okay, let's see. 3.2, we are given, that was a word problem actually here, 5 marks for this word problem. So let's just see what are they trying to say here. They are saying the second angle of a triangle is 5 times as large as the first angle. So as we can see from this statement, we are given from a triangle, and the reference is the first angle because we are told the second angle from the first angle. They are saying it is 5 times. So meaning to say, if it is given from the first angle, we can refer our first angle as x. So you can just say, let the first angle, you're gonna have, let the first angle be x. Okay, so if our first angle in this case, let's say it's x. So if this angle is x, they are saying the second angle is 5 times as large. 5 times means you are multiplying, all right? 5 times, it's 5 multiplied by, okay? You multiply that to x, which is gonna be 5x. So if it is 5 times, it means it's gonna be 5x. So that's our second angle is gonna be what? 2x, 5x from that, okay? Because we are told it's 5 times. So this is our second angle. Then they're saying the measurement of the third angle is 12 degrees greater than that of the first angle. Take note, greater is 12 degrees greater. Greater, it means 12 degrees more than this. So if something is more than, you add. So meaning to say it is 12 degrees more than the first angle. And what is our first angle? Our first angle is x. So it's going to be x plus 12. That is 12 degrees greater, we add 12 to that x. So that will be our third angle, x plus what? X plus 12. So the question is, determine the size of the angles of the triangle in degrees. So we are supposed to determine the size of the angles of this triangle, this one x, the 5x, and the x plus 12. So in order for us to have these angles, we are supposed to calculate the value of x. From where? Yes, it's a word problem, but we are now back to the normal properties of a triangle. Understand that in a triangle, these interior angles, the angles that are inside the triangle, they add up to 180 degrees. So it means if we combine everything, the first angle, which is x, plus the second angle, which is 5x, plus the third angle that we got as x plus 12, we are supposed to get the sum of 180 degrees, which is the total angles of a triangle. So this gives us the opportunity to find the value of x. Since this is an equation, this is same as 1x, we're going to add 5 plus 1, which is 6 plus 1, which is 7x, plus 12 is equal to 180. So that's 7x is equal to transpose 12 to the other side so that you can subtract. That will be 180 minus 12, which is 168. All right, so just divide by 7 since you're multiplying. So x is going to give us 24. If we divide properly, x is going to be 24, which is 24 degrees. All right, so now let's analyze our angles, because we said the question needs us to find the angles. So the first angle, which is x, is going to be 12 degrees. Okay, we got our x as what? As 24, not 12. So this is 24, not 12. This is 24 degrees. The second angle, we said 5x. So the second angle is going to be 5 times 24, which is 5x. So that's 5 times 24. If we multiply this properly, it was going to give us 120 degrees. Then the third angle, we said it's 12 degrees greater than, which is x plus 12. So x, remember, is 24. So it's going to be 24 plus 12, which was going to be 36 degrees. So these were the angles that you're being asked, the first angle, the second, and the third. And if we add everything, we must get 180 degrees. This is to show that we are truly having this from a triangle, because these angles in a triangle, they are supposed to add up to 180 degrees. All right, so that was it. Just understanding your word problem, then understanding also the properties of a triangle. They were testing you a lot of things here. One, to formulate from the word problem, and also to understand the properties of a triangle. All right, so for x, that is 5 marks for that. So this is the equation that we are given, and we are asked here to solve for x. All right, so if we are to consider this, we can see that we have got x plus 1, which is fine, and so forth. But here on this one is 1 minus x. Remember, I always say that you're supposed to start with the variable. If you're starting with x, this is x, this is x, you are supposed to start with x also on this one. So 1 minus x, we must start with x and also being a positive. So how do we do that? All right, so this is x plus 1 over x minus 1 is equal to 2. That is a -2, this one, -2 over x plus 2. Then this is minus x plus 2 like this. So what you're going to do is that on this 1 minus x, we are going to write it as minus x plus 1. We just want to start with x, but this x must be positive. So we factor, okay, here we didn't change out anything. This is 1, which is the same as this one. All right, this is minus x, same as this minus x. So we haven't changed anything, but we want it to be a positive x, just like these other x, they are positive. So how do you do that? You factor out a negative. The moment you factor out a negative here, this becomes a positive. Negative and divided by a negative, it gives us what? A positive. Okay, so it's negative, which is what? A positive x. Positive and a negative, they give us what? A negative. So this will be a negative there. So meaning to say, this whole part of 1 minus x, in simpler terms, what we wanted, having this as a positive x, it can be written as minus x minus 1 like this. But we have a negative and a negative. These two signs, they are going to affect each other. The negative here and the negative here. This gives us a positive at the end. So meaning to say we are going to have x plus 1 over x minus 1, which is equal to negative 2 over x plus 2. Also, like I said, we said negative is going to be a positive. So that will be positive x plus 2 over x minus 1. Okay. This is our equation. And as we know that if we've got this now in this format, like what we have, we can now clear our fractions considering the LCD or the LCM of everything in this case, or our LCD, which we can consider. We've got x minus 1. We also have x minus 1 in our denominator, which is just appearing once. And we also have x plus 2. So this is our LCD. All right. So what do? We have to multiply each and every term by the LCD. Okay. So meaning to say here, we are going to multiply by the LCD, which is multiply by x minus 1, x plus 2. Okay. The same thing here by x minus 1, x plus 2, each and every term. Also here by x minus 1 into x plus 2. So the moment we do this, it enables us now to cancel this, because this is same as over 1. So you can be able to cancel the x minus 1 and the x minus 1. You'll be left with x plus 2 and x plus 1. So these are the two parts that you're going to consider. The bracket of x plus 2 left and the bracket of x plus 1 that is left. This is equal to, so this whole part is equal to, you do the same thing. The bracket of x plus 2, the bracket of x plus 2, they do cancel. So we are going to be left with negative 2 and x plus 1. So this will be negative 2 into x minus 1. We do the same thing on this part. The x minus 1 and the x minus 1 do cancel. You are left with x plus 2 and x plus 2. And remember that x plus 2 and x plus 2 simply means x plus 2 squared. So we've got x plus 2 into x plus 2, or just x plus 2 squared. So this is where we are now, whereby we can expand our brackets and so forth. Remember, by distribution, x is going to multiply everything. So it's x times x, which is x squared. So remember that x multiplies everything. So this would be x squared, okay? X and 1, which is going to be x. We are done with x. We move on to 2. So it's 2 times x, which is going to be 2x. 2 times 1 here, which is going to be positive 2. This is equal to negative 2 times x. That's negative 2x. Negative 2 and negative 1. Negative, that's a positive 2. If we are to do the same thing on this part, we must have this a plus. So a plus does not affect. So just expand and write your answer. Unless if it was a negative, you must open a bracket. But so you can just distribute, or you can use your laws. I mean the theorems that you can actually use on your expansion of brackets, just like we know x plus 2 squared can be given as x squared plus 4x plus what plus 4. But if you do not understand this, guys, do not worry. Just expand, because you know this, that there are two brackets here, x and x here, which would be x squared, x and 2 here, which would be 2x, 2 and x here, which would be 2x, 2 and 2 here, which is going to be a 4. So expand properly, then collect the like terms. So consider what is on the left-hand side and what is on the right-hand side separately, so that you don't confuse yourself, okay? So let's consider what is on the left-hand side. Gonna be left with x squared. This is 1x plus 2x, which is gonna give us 3x plus 2, all right, is equal to, you consider what is on the right-hand side now, this part on the right-hand side. So this is going to, we have got x squared. So you're going to have x squared here. All right, so let's consider, let us just take our calculator, guys, and consider the part of x so that we do not make mistakes. So This is -2 here, +2, and actually there's no need for a calculator there because -2 and +2, they do cancel. That's a 0. The -2 and +2, that's a 0. So you'll be left with 2x. So this will be plus 2x, okay? On the numbers, we've got 2 and 4. 2 plus 4, which is going to give us a 6. So 2 plus 4, that's a 6 in this case. All right. So in actual sense, now we can be able to transpose, but by just me looking here, there's an x squared and there's an x squared here. Whether I transpose this side, or I transpose this the other side, one way or the other, they're going to cancel. X squared, if it goes this side, is going to be minus. So x squared minus x squared, that's a 0. So the x is going to cancel. We are left with this part. So now we can just transpose 2x to this side because it's now a linear equation. So you have to collect the terms of x to one side and the constants to the other side of the equation. So by doing this, we are going to be left with 3x. All right, so this will be 3x. If we transpose 2x to this side, it becomes a negative. So that is minus 2x is equal to, transpose 2 to the other side, it becomes a negative. So it's 6 minus 2 like that, okay? So let us simplify and see. 3x minus 2x, this is x is equal to 6 minus 2, which is going to give us what? Which is going to give us a 4. All right, so that is the value of x that we are going to have at the end. Our x is going to be what? Our x is going to be equal to 4. So whenever you are solving these, whenever you are dealing with these typical equations, you have to try by all means, to work out your fractions first. All right, this part of the fractions, try by all means to write it in the way that you properly understand. Clear your fractions because you have got the denominators that are the same. Find the LCM or the LCD. With that, you multiply each and every term by the LCM or the LCD. Once you have cleared your fractions, you are left with the brackets. Clear the brackets, collect your like terms. Yeah, that was going to be enough in order for you to obtain the full marks on this question. So that was a question 3, 13 marks on everything. So let us consider other part of the question and see what we are given, which was on question 4. All right, so question 4, we are given the part of our analytical geometry, the part of our geometry. If you're dealing with the geometry, that part. Fig A shows the point A, you've got point B, and so forth. These are the vertices that you're given. P, which is given as XY, is the midpoint of the line segment AB. So this P that we see is the midpoint that we are given here. So this one, we are told that it is the midpoint. All right, so I think this one is a straightforward question. Everything is just clear on this diagram. All right, let's see. The first question, determine 4.1, the gradient of the line AB. So we need the gradient of the line AB in this case. So like I said, this one, it seems like it's a straightforward question. If you are to consider the gradient of AB, this is a point A and your point B. Remember, the gradient is the change in Y over the change in what? Over the change in X, okay? So that is our question 4.1. So the gradient of the line segment AB is going to be Y2 minus Y1 over X2 minus X1, of which you can use Y1 minus Y2, which is fine. So this is our point A, which is our first point, B, our second point. So Y2, that's the Y value at point B, which is 6, minus the Y value at the first point, which is Y1, which is minus 2. So that's a -2. Remember, that's 6 minus 2. The point there, it's 6 minus 2. Okay, you do the same on the X value. The X at point 2, which is 2, minus the X at point 1, which is 6. So this was going to give us 8 over minus 4, which is minus 2. So we've got a gradient there of -2. That's the gradient of what? Of AB. All right, 4.2, the size of theta, the angle of inclination between line AB and the x-axis. All right, so you need to determine the size of theta, and truly theta here is the angle of inclination. As you can see, that is where we have our theta, which is this angle here, the angle between the line and the positive horizontal axis. But as you can see, because our gradient is a negative, it means this angle that you are going to have here is going to be an obtuse angle. You must obtain an obtuse angle. So how do you simplify that? Yes, you can simplify. You know that you're supposed to have your theta as arctan, but now it is not going to be like that. You are going to determine from your arctan, it is going to be the reference angle that you're going to calculate in that case. So your reference angle is the one that you must obtain from arctan, and don't consider the sign that negative, just take it as a positive as it is as 2. So we are obtaining first the reference angle that we are going to use. Remember, I told you whenever there are two angles that you have to compare, the one that you do not need is your reference angle. Okay, so it's arctan, which is shift tan 2 like this. Okay, so this is going to give us the reference angle, which is the acute angle of 63,43 and so forth. So you can just round off to 3 decimal place. So fix this to 3. It's going to be 63,435. So this is 63,435 degrees. That's your reference angle, this one. But what about theta now, which is the exact angle, this one, theta? So like I said, it's an obtuse angle. What we have determined is this acute angle, this one. So we have to subtract it from 180 now to obtain the exact angle theta, which is the reference angle, which is the exact angle now that you're asked. So theta is going to be 180 degrees minus the reference angle, which is 63,435 degrees. All right. So this was going to give us the exact value of theta now, which is 180 degrees. So we are going to subtract 180 minus the answer. All right. So for that, minus the answer that we got. All right. In fact, I've already removed this. Let me just redo 63,435 like that. All right. So this is going to give us the angle, which is now the exact angle that we want, which is 116,565. So this is 116,565 degrees. All right, so this is the theta, the angle that we are supposed to have obtained, not this 63. This one is just your reference angle. Even if you use arctan -2, you're going to get this as a negative there. You have to remove that because it's not the exact angle that you're being asked. Okay, so that was our 4.2. This is 4.2, not 4.1. All right, this is 4.2. All right, then 4.3, we are given the coordinates of P, the midpoint of the line AB. So we are given the line segment AB in this case, right? So this P, we are told exactly that it's a midpoint. So how do you calculate the midpoint? Remember, the midpoint, you add the X values, divide by 2. The Y values also divide by 2. So that's 4.3. So P is just going to be X1 plus X2 over 2. You add the Y values together, you divide by 2. So that was going to give us the point P. So if you consider is the midpoint of what? Of AB. So you're just going to add X here, it's 6 plus the X value, which is 2, everything over 2. The Y value here, it's minus 2. The Y value there, it's a 6. So it's minus 2 plus 6. Minus 2 plus 6, everything over 2 like this. All right. So that's the midpoint of a line segment. So this was going to give us the point P. 6 plus 2 over 2, which is going to be 8 over 2, which is 4. And this is going to give you a 2. So that was going to be the point P that represents the midpoint of the line segment AB. All right, we have got our point P. let's consider 4.4, the distance A and C, between A and C in simplest said form. In simplest said form, it must be in the simplest said form, not just in said form, but the simplest said form. All right, remember, this is distance, all right, distance between A and C. So you can just consider our distance formula. That's our point A and our point C here. So this is 4.4. So remember, from our distance formula, we are supposed to have the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, so that means between A and C, we're just going to subtract the x values, A and C. That's x here, it's minus 2. This point is minus 2, 2. So the x value there is minus 2. So it's going to be the square root of minus 2 minus the x value here, which is 6. So it's minus 2 squared plus y, the y value here, which is a 2, minus the y value on this side at point A, which is negative 2, this one. So it's going to be minus 2 like this. So it's going to be a plus. So that was going to give us AC. So you can even simplify on your calculator negative 2 squared, which is going to give us 64, plus 2 minus 2 squared, which is going to give us a 16. And we can determine the value of AC, which is the square root of 80 in that case. But they said in the simplest form. So if you do not know this to simplify in simplest form, you can also just use your calculator to do that. All right, so let us just use our calculator and see here. Go back to the normal mode, which is 2. So we need the square root of 80. So this is the square root of 80 like this, which is 4 square root of 5. So that was going to give us 4 square root of 5 in what? In simplest form, okay? That is as a simplest said in simplest form, which is the said form. All right, 4.5, we were now given to find the equation of the line passing through the point A. Take note here what they are saying. We need the equation of the line passing through the point A that is parallel to the x-axis, all right? 1 mark for that, or 2 marks. Parallel to the x-axis, passing through the point A. All right, this is our point A here. If we need the equation parallel, it means we are going to take, all right, parallel to the x-axis or x-axis, we're going to take the y values like this. It is the line passing through A like this. So we consider that is the line of y is equal to every line that is parallel to the x-axis. Remember, the x-axis is y is equal to 0. So on this one, what is the y value? The y value is minus 2. So the equation is y is equal to what? Y is equal to minus 2. So the line parallel to the x-axis, that one passing through, that is y is equal to minus 2. Then the equation of the line passing through the point B parallel to the y-axis, all right? So now it's parallel to the y-axis at point B. This is our point B here. Parallel to the y-axis, it means it's like this. So we must consider the equation in the form of x is equal to, at this point, x is 2, so it's going to pass at 2. So the equation of the line is x is equal to what? X is equal to 2. That is the one parallel to the what? To the y-axis. So x is equal to what? To 2. All right, then 4.7, determine the coordinates of the point of intersection of the two lines. X is equal to minus 4 and y is equal to y is equal to 7. This is just x is equal to minus 4. We are just talking about a vertical line and a horizontal line. Where these two meet, that's the point of intersection at x and at y. So x there is minus 4, y is 7 as a point. We are not solving anything. Already your equations, they are solved. You are already given the value of x and also the value of y. You already have that. Okay, so that was your question. Then 4.8, they are saying determine the equation of the line through the origin and B. So it's through the origin and B. It passes through the origin and B. So remember the origin is 0, 0 about the origin. That's here at 0, 0, okay? So if it passes through the origin and also passes through B, what is going to be the equation, all right? That is our question 4.8. So remember our equation in the form of y is equal to mx plus c. We are supposed to have m, which is the gradient, all right? So we have got 2 points B, which is the point 2, 6, and passing through the origin, which is 0, 0. So in order for us to have the gradient, we're just going to subtract 6 minus the y values, you subtract them. So the change in y, remember, so that's 0 minus 6 over 0 minus 2, which is going to give us a positive 3. So we have got the gradient. So that means y is equal to mx, which is 3x plus c. So to find the c, we're actually supposed to substitute one of the points. You can substitute 0, 0, you can substitute 2, 6. But by the fact that it passes through the origin, it means you are already given the y-intercept. The line is supposed to pass like this. So it passes through the origin, where the y at the origin is 0. Remember, C represents the y-intercept, and at the origin, y is equal to 0. So therefore, our line was going to be y is equal to 3x. But like I said, you can even substitute any of these points that you want. You want to substitute the point B on y is equal to 3x plus c, and you've got the point B, x and y, x being 2, y being 6. So 6 is equal to 3 times x, whereby x is 2 plus c. 6 is equal to 2 times 3, which is 6 plus c. Transpose this to the other side. 6 minus 6 is equal to c. So that's a 0 is equal to c. So as you can see, we can also prove that this c is equal to 0, just like the part that we talked about from the y-intercept. So that was your equation, y is equal to 3x. All right, then 4.9, the equation of the line passing through point B, take note, it is passing through the point B, same point B, that is perpendicular to BC. All right, leave your answer in the gradient intercept form. So it is perpendicular to BC. Have we calculated the gradient of BC before? BC, we never calculated the gradient of BC, no problem. So we told that it passes through B and perpendicular to BC. So this is the situation that we are going to have. It must pass through the point B like this, and perpendicular, meaning to say it is supposed to be at what? At 90 degrees, passing through the point B at what? At 2, 6. So what is the condition that a line must be perpendicular? For two lines to be perpendicular, the product of their gradients should be equal to -1, the product. So we can take advantage of this line because we have the point BC. It's perpendicular to BC. So you can consider finding the gradient of BC, which is the change in y over the change in x. Y minus y there, that's 2. Minus 6 over x minus 2 minus 2. All right, so you subtract the x values, minus 2 minus 2. You're going to obtain the gradient of the line BC in that case. And the gradient of the line BC in this case was going to give us a +1. All right, but remember I said the line that we want to calculate its equation and this one, they are perpendicular. So if they are perpendicular, the product of their gradients, which is the gradient that we want, times the gradient of BC that we have must give us a -1. And we have that the gradient of BC is 1. So it means our m was going to give us what? A -1. If we divide by 1 both sides, this gives us m, which is -1. So the gradient of the line that we are supposed to calculate its equation is -1. So if the gradient is -1, therefore the equation is going to be y is equal to mx plus c. Y is equal to m, the gradient, -x plus c. So you're going to substitute the point that we are given because it passes through B, and B is given as what? As 2, 6, the value of y there being a 6. So 6 is equal to -x, which is -2 plus c. So you can transpose the -2 to the other side, it becomes a positive. So that's 6 plus 2 is equal to c, 8 is equal to c. So therefore, our equation at the end of this line was going to be y is equal to minus x plus c, which is minus x plus c, which is 8 in that case. We got our c as what? As 8. So this is the equation of the line that we're going to have at the end. So these are the typical questions. We just have to be very careful how our questions are given. So that was 19 marks on actually on everything on this question. Let's see the other part of the question. They were given to draw the graph of y is equal to 2x squared in the answer book, show the turning point and so forth. So actually the graph of y is equal to 2x squared, guys, is actually nothing. If we were to have this even on the graph paper, we're just going to have something of this nature. There's nothing that was important on that part, but they're saying in the answer book, so it was just a sketch that you're having. So you can just have your x values and your y values, okay? Like we've got 1, 2, and so on. That's 1, 2, 3, minus 1, minus 2, minus 3. So you're going to see that for the graph of y is equal to 2x squared, it is going to be the same values for what we have in the x values. The y values, they're going to be the same. If a value is a positive and another one is a negative, like we have minus 3, minus 2, minus 1 is 0, 1 and 2 and so on and so on. So you can just use a table just to formulate to see how the shape of the graph, how it is supposed to look like. So this is 2x to the exponent of 2, and the first value of x that you're given on the negative 3 is going to be 2 into x, which is negative 3 squared like this, which is 18. So you're going to have 18. We substitute a negative 2, just going to see what's happened here, which is 8. Substitute a negative 1. All right, I want you to see what's going to happen here. That's a positive 2 as 0. It's going to be a 0, a 1. Okay, let's go to 1. I want you to see what's going to happen in 1. If we put a positive 1, we're going to get a 2. Let's put a 2. If we put a 2 here, we are going to get an 8. It was going to be the same thing for 3. If you put a 3, it was going to give you 18. So if you check this graph that we are simply having, it's a repetition of what we are having on the left-hand side. As the values are increasing in terms of y going in the left as they are increasing, we are having the same scenario on the right-hand side like that, all right? We are having the same scenario. They are the same values for the x and for the y, all right? I mean, for the y from the x, which is being a negative, and from the x, which is being a positive, the y values, they are the same. If we consider these are the y values, these are the y values that we are having, but all being taken from the point of what? Of 0. They are from the origin going up, origin going up. All right, so that was the graph of y is equal to 2x squared, which is our f of x. Just okay, this one is enough. And our turning point of this graph, as we are asked to indicate the turning point, that's at 0, 0. This one is our turning point. It's at 0, 0 for this graph because the y-axis is our axis of symmetry, which is the line of x is equal to what? The line of x is equal to 0. So that was it. All right. So we need the turning point. Show the turning point, the axis of symmetry. So the axis of symmetry, like I said, is the y-axis, which is the line of x is equal to 0. That's your axis of symmetry. This is your turning point. The solutions are at 0. So I think that was enough for you to obtain all the marks, of which is that's 3 marks for that, okay? 5.2, we are given determine dy dx, given that y is equal to this part, all right? By the means of the rules of our differentiation, leave the final answer with positive exponents and in said form where applicable, show all the steps. All right, so let's try and see our question. That was 5.2. So on this one, we're given that y is equal to 2 over x minus 2 the square root of x plus 1 over 3x, 1 over 3 x to the exponent of a 3. Remember how you differentiate that. In order for you to differentiate, you must have the format of a x to the exponent of n, and we know that the derivative of this is going to be an x to the exponent of -1, where you drop the exponent and you subtract 1 on the exponent. So that's the first thing to rearrange. 2 over x is same as 2x to the exponent of a -1 minus the square root. Remember, it means to the exponent of a half. All right, plus a third x to the exponent of 3. So now we can be able to determine the derivative of y with respect to x. Remember the concept. We have to multiply these two. We drop this exponent to multiply with a. So we're going to multiply this with -1. -1 times 2, which is -2x. Then we subtract 1 on the exponent. So it's -1, which is -2. All right, we do the same thing. We multiply the exponent, multiplies here, -2 times a half. This is -1. So it's same as -x to the exponent of our half. There, we subtract the exponent. We subtract 1 on the exponent. So it is going to be -half. All right, we do the same thing. Drop the exponent, a third times 3, which is going to be 1. So that is just going to be x. Then we subtract 1 on our exponent. So 3 minus 1, that's a 2. But we are told that we are supposed to have our answer as positive exponents and also in said form where applicable. So we're going to remove our negative exponents. Remember, a negative exponent simply means 1 over. So our dy dx in this case here, gonna remove a negative. So that will be -2 over x squared, minus, to remove the negative here, it's gonna be 1 over x to the exponent of a half plus x squared. Okay, we have removed negative exponents. We now have positive exponents, but this can be written in what? In a said form. Remember, said form is writing your answer under the square root, and this is very, very applicable because you know to the exponent of a half means the square root of. So that is the square root of x plus x squared. So this is now in simplest form. As you can see, all our exponents, they are positive. That is the first thing. And 2, they is, or they are in said form where it was applicable. Okay. So these were the steps that we're just supposed to take, understanding that in order for you to have a derivative, to differentiate, the format is supposed to be like this. We are supposed to have this format, then this is the derivative. All right, then once we have that format, we'll be able to differentiate everything. And don't forget to simplify your answers as far as possible as per the instruction of the question. All right, so that was 5.2. 5.3, we are given f of x. If f of x, consider that f of x is 2x cubed plus 6x squared. Make use of the differentiation to determine the coordinates of the turning points of f of x. All right, so you need to determine the coordinates of the turning point. All right, so remember, for a function that we are given, whatever function, here we're given 2x to the exponent of 3 plus 6x squared. It follows that at any turning point, I said the first derivative of that function must be equal to 0. Okay, you consider the first derivative of that function to be equal to 0. So meaning to say here on our f of x, we're going to need the first derivative. So what is the first derivative? The first derivative is going to be what? Multiply here, it's going to be 3 times 2. Remember, I said we drop the exponent. 3 times 2, which is 6x. Then we subtract 1. So 3 minus 1, that's a 2. We do the same thing, drop the exponent here. So it's going to be plus 2 times 6, which is 12x. We subtract 1. So 2 minus 1, that's a 1, which is just going to be 12x. So from the first derivative that we are given, we are saying the first derivative must be equal to 0. And this is our first derivative. So what are we going to do with our first derivative? We are going to equate this first derivative to 0. That means this part as it is 6x squared plus 12x must be equal to 0. So we now have a quadratic equation that you can be able to solve by your factorization method. You can just factor out 6x, which is the highest common factor. 6x squared divided by 6x, you get x. plus 12x divided by 6x, which is plus 2, which gives us a 0. So each bracket or each term must be equal to what? To 0, or x plus 2 also must be equal to 0 on this part. So the first one, it means we divide by 6, x is just going to remain here as what? As 0. So x is going to be 0, or on this one, if we transpose this side, the minus the 2, it becomes what? A negative 2. So these are the x values that we are going to need at the turning point. But the question needs us to determine the turning points, not the x values at the turning points, no. So the turning points, we are now talking about the x at the turning point, which is 0, you determine the value of y. And when x is minus 2, you determine the value of y in that case. So when x is equal to 0, you substitute into the original function f of x. You have to go back to the original function in f of x. You substitute as 0 where there is an x here, that y is going to be equal to what? To be equal to 0. You do the same thing when x is minus 2, y is going to be equal to 8. You substitute into the original equation that you are given in that manner. Okay, so that was how we're supposed to have this question. All right. Then the other part of the question now, they're saying draw the graph of f of x and show on the graph paper. So this one they actually needed us to draw on the graph paper. But here I'm just gonna use this information not on the graph paper, but I'm just gonna show you how it was supposed to look like on your graph paper. Remember, you're supposed to draw the graph of f of x. We have the turning points of this graph so far. This is what we calculated from the previous question. All right, so that's 5.32. Remember, our f of x, it was given as what? Our f of x was given as 2x cubed plus 6x squared. So we now have the turning points, and also from the shape that we are seeing, we can consider that our shape is supposed to be something of this nature, okay? Going to the positive, because here, A, it's a positive. So our graph is going to be into the positive, okay? Then from this turning point, we can also consider the intercepts, okay? That is the x-intercepts, where we know that y must be equal to 0. So if y is equal to 0, it means 2x cubed plus 6x squared must be equal to 0. So you can factorize just like the previous case, where we have got the highest common factor between the two brackets, which is 2, and we can factor out x squared, the one with the smallest exponent. So 2x cubed, when divided to 2x squared, we're going to have x, 2 and 2 cancels, plus 6 and 2, that's a 3x squared, and x squared cancels, which is equal to 3. One of these must be equal to 0, so that's 2x squared must be equal to 0, or x plus 3 must be equal to 0 in that case. So we are now solving, we are finding the x-intercepts here. Divide by 2, that's x squared is going to be 0, so x is going to be the square root of 0, which is 0. But being a squared like this, it means we are supposed to have two solutions. It's just like x squared is equal to 4 plus or minus 2. So if we say x squared is equal to 0 and we've got plus or minus, it means here, this point that we are saying is a solution, it's also a turning point. This x value at 0. Yes, it's a solution, the x-intercept, but it's also a turning point. If we go back to the turning points, we are going to see that there is a point 0 there, which is this one. So that is the indication that we are seeing. There are two solutions, but it's going as a one solution. It means that point is going to be a turning point. So your graph, if it is at 0 like that, maybe your graph is like this. When it goes to 0, it goes back. It's a solution and a turning point. So our graph is not going to have 3 solutions like this. We've got 1, 2, 3. Okay, our graph is not going to be like that. Okay, then the y-intercept, when y is equal to 0, as you can see, guys, when x is equal to 0, y is going to be equal to 0. So the y-intercept, that's 0, 0. All right, that's 0, 0. So you can just try to have our sketch, but as you are told there, you are supposed to use the graph paper. But as for me, I'm just going to have it in form of a sketch. All right, so this is what you were supposed to have. Your x-axis your y-axis at the point 0, which is our origin, okay? So let's consider the solutions. Remember we said the solutions, 0 here, x plus 3 is equal to 0, so x here will be equal to minus 3. So we have got a solution at minus 3, maybe this is minus 1, minus 2, minus 3, somewhere there, 1, 2, 3, and so on. So we've got a solution at minus 3 and also at what? At 0. But this one that we have, this one, remember I said this one, it's a turning point, all right? It's a solution, but at the same time, it's a turning point. So on your simplification, this is what you're going to do. We are supposed to have a turning point at 0, 0. Remember, this one is a turning point. The shape, we talked about the shape before. And there's another turning point at minus 2, 8. This one that we have here at negative 2, 8. So in between negative 2 here and 8, maybe your 8 is somewhere there. There's a turning point there at negative 2. At negative 2 versus what? At negative 2 versus 8, maybe somewhere there. There's going to be a turning point. So you're going to join your graph in that manner from negative 2 in the ground here, passing through negative 2 to the turning point at negative 2. This is passing through negative 3 to the turning point at negative 2. And it goes back. We are supposed to have a solution. We are supposed to have a solution like this. But now we do not have any other solution that is going to happen this side. That's where I was saying when it is now going back here, this solution is a turning point also. We are seeing it on the solution at the turning point, which is at 0. So here your curve or your graph is going to have a curve like that to show that this point here at 0, it's a turning point and it's also what? A solution. So that is our function of f of x, all right? So the question there was for you to sketch, to draw this graph and let us just check if there's anything that we need to indicate on this graph. We just draw, all right, draw this one, calculate, all right, so it was not like, all right, but just for interest sake, you can even indicate your 10 points. Remember I said 0, 0 and minus 2, 8. So you can just indicate our turning points. Here is a turning point at minus 2, 8. That's a turning point. And also this one is a turning point, which is 0, 0. Okay, so that was our function that we're supposed to have a sketch. So these are the typical questions, how they are actually given on the sketch. But here, you're supposed to draw it properly on your graph paper. So, but you're supposed to have exactly the same shape, the same way I'm presenting this one. This is what we are supposed to have on your sketch. All right. On question number 6, we are now given that is the trigonometry part, and here we are asked 6.1 to use the basic trigonometric identities to prove that this part that we have and this are the same. 4 marks for that. Okay. How are we supposed to prove this? Okay. Remember, for proving a certain trigonometry, you're supposed to choose a side that you can work from. So, and I always ask you guys to work with the most complicated side, the one that has got a lot of things, like the left-hand side. You can see there's a lot to be simplified there. All right. So on the left-hand side, we are given, in this case, the tan of A. So that is the tan of A over 1 plus tan squared A. So this is 1 plus tan squared A. All right, so we know that 1 plus tan squared is equal to sec squared. This is an identity that we know that this is equal to sec squared from our information sheet. We are also given this. So meaning to say we are going to be left with the tan of A over sec squared A. This is an identity that we are just taking from your formula sheet. We are also given this. Then considering the tan and the sec, we are dividing here. And we understand that tan is equal to sine over cos. So this can be given as the sine of A over the cosine of A being divided to sec squared A. And we understand that sec means 1 over cos. So we are dividing to 1 over cos squared A, because it's sec squared. So it must be 1 over cos squared also. All right. So this is going to give us the sine of A over the cosine of A times. Remember, whenever you've got a division, introduce a multiplication, invert the second fraction. So it's going to be cos squared A over 1. So by looking properly, you can see there's cos A. There are 2 of them. So if we cancel, we're going to remain with 1 cos A. So this is going to give us sine A cos of A. And this is exactly what we had on the right-hand side, sine A cos of A, which is sine A cos of A. So this is exactly what we have on the right-hand side. Okay, so that is how we can prove a certain identity given certain identities to be used together or in conjunction to find whatever that you're given. The 6.2 you're given, the cos of A is equal to, we are given that it's -5 over A, and theta is taken, our A is taken from 0 to 180. So there are 2 things that we must consider. The first thing is that our cos is a negative. Cos of A is -5 over 13. And the interval of A from 0 to 180, meaning to say we are working with the 2 quadrants, the first and the second, that's 0, 90 degrees, 180 degrees. And in between these 2 quadrants, where do we see our cos being a negative? All right, in the first quadrant, we know that all of these, they are positive. All right, so from the cast concept, here in the second quadrant, cos is what? It's a negative. So this means the diagram is supposed to be in the second quadrant. From 0 to 180, we are working with these 2 quadrants only, and cos cannot be negative in the first quadrant. So we are just going to have a sketch in the second quadrant, and you know what it means? We're gonna have a right angle triangle here. These are the x values, these are the y values, and this is the angle A that we are talking about. And from the ratio, of course, from our soccer tour, that means from our soccer tour here, it means cos is adjacent over the hypotenuse. So this is the adjacent, and this is the hypotenuse. So according to this, our adjacent is -5 here, the hypotenuse, which is 13 here. So you're going to use your Pythagoras theorem to determine the third side so that you can be able to simplify whatever that you are being asked in there. So remember, from your Pythagoras theorem, it states that the hypotenuse squared, which is 13 squared, is equal to x squared plus y squared. So this is going to be -5 squared plus y squared. 13 squared, which is 169, is equal to 25 plus y squared. Transpose this, it becomes a -169 minus 25 is 144. So 144 is equal to y squared. So to find the value of y, just introduce the square root both sides. That was going to give us the value of y, which is plus or minus 12. But as you can see, our y value is above the x-axis on top, so it cannot be a negative. This one is going to be a positive, okay? So after finding this, we can answer our questions now. The first question, which is 6.21, was to find the value of tan A, and tan is the ratio opposite over the adjacent. So this is opposite over the adjacent. According to this angle, the opposite is 12 over the adjacent, which is -5. All right, so remember, we are talking about this angle. This is our opposite, our adjacent, and our hypotenuse. But we can just write the negative on top. So that's -12 over 5, like this. Okay, then the sec of A on 6.22. All right, so remember that the sec of A represents 1 over the cos of A. All right, and we said cos is the adjacent over hypotenuse, so it's a reciprocal. So if it is 1 over cos 8, is the reciprocal, so it's going to be the hypotenuse over the adjacent. All right, so you're going to have hypotenuse over adjacent, or you can find cos, then 1 over the cos, okay? Which is the hypotenuse in this case is 13 over the adjacent, which is -5. So this is same as we've got -13 over -13/5. All right, so that was the sec of A, or just 1 over cos because it's the reciprocal. The answer for cos, just divide it by 1. Okay, 6.3. We're asked to consider this fig that we are given here, the 2 points and so forth. The angle of elevation is 25, and that one was 47. That we are given between the 2 points. And the question is, in this case, consider this, all right, angle of elevation and so forth, B and C. All right, so our question was actually to find BD. All right, that was the question, to find BD. All right, so you're supposed to calculate this BD. The part of the question has just disappeared, but you're supposed to calculate BD in this case, which is this one, the height, which is this part of BD. So to calculate BD in that case, what can we do? All right, if we consider this triangle, we can calculate BD if we have either we've got BC or CD. We can use that from our trigonometric ratios, but we do not have any one of these. So let's think about this triangle here, because we want to calculate any one side that can be on this triangle here, which is the side BD. So how can we calculate BC? Because it's part of this triangle. Let's just fill in. This is from 180 degrees. Remember, angles on a straight line. 180 minus 47, it gives us 133 here. Angles in a triangle, you know that they add up to 180 degrees. So 180 minus this angle and this angle, we get this angle that is remaining here, which is 22 degrees. So as you can see, the 22 is corresponding to 5. The 25 is corresponding to BC. So we can use the sine rule to calculate BC. Whether you use it as sine of A over this or whatever that you want to calculate BC first. So it's going to be BC over the sine of the angle BC. It corresponds to sine 25. All right, is equal to what we are given, 53 over the sine of the angle. It corresponds to 22. So it's the sine of 22 degrees. So you can calculate BC. Just remove this, multiply by sine 25 both sides, multiply by sine 25 both sides. So this will cancel. We remain with what? With the BC. So BC was going to be, this is 53 sine of 25 degrees over the sine of 22 degrees. So that was going to give us a BC, which is to 3 decimal place was something like 59,793 meters, right? Which is this BC, which is, if it is 59,793 meters, then we can use it now to calculate the side BD. From our trigonometrical ratios, we can see that according to the angle of 47 degrees, we are now in this triangle here, in this triangle. According to the angle of 47 degrees, BD, the side that we want to calculate, is the opposite. It faces this angle, so they are opposite to each other. And this is hypotenuse, the one that faces the 90 degrees is our hypotenuse. So which ratio uses opposite and hypotenuse at the same time, so that we can calculate the side BD from our trigonometrical ratios? We have got our SOHCAHTOA. There's only one ratio that has got opposite and hypotenuse at the same time, which is the ratio of sine. Sine of theta is opposite over hypotenuse. So writing this, when I have the sine of theta, theta is the angle, which is the angle of 47 degrees, is equal to the opposite, which is the side that we are supposed to calculate, which is BD, over the hypotenuse, which is the one that we calculate, which is BC. That's 59,793. So this is same as over 1. You can cross multiply to calculate BD in that case. That's 1 times BD, which is going to be BD is equal to this times this, which is going to be 59,793, the sine of 47 degrees. So this is going to be the sine of 47 degrees. So this is going to give us BD, which was going to be something like 43,7298 and so on, which is 730 to 3 decimal places in what? In meters. So this is the length that we are being asked to calculate, the length of BD. So those are the stages. Apply your sine rule from the non-right angle triangle. You find a side that you're going to use on a right angle. On a right angle triangle, you use the trig ratios. They are used on a right angle triangle, the sine rule, because it's a non-right angle triangle, okay? Then the last part, which was actually 6.4, was to sketch the graph. Sketch the graph of f of x is equal to 2x, all right? So this is our function. F of x is equal to 2 cos x plus 1 from 0 to 270. So in order for you to just draw this or sketch this, you can just choose how to separate your angles. Like I said, normally for the graph of cos and the graph of sine is best for us to use the interval of what? 90 degrees. So you're going to have our x and our f of x, which are the y values. If we separate by 90 degrees, it means we're going to have 0. 0 plus 90, that's 90. 90 plus 90, that's 180. 180 plus 90, which is 270 degrees. All right. So what you're simply going to do is to substitute this on your calculator so that you determine the y values. If you substitute into your f of x, which is 2 cos x plus 1. So this is what I'm trying to say. Making sure that your calculator is in degrees. We're going to have 2 cos x, that is 2. The cos of x, if x is 0 like this, we are going to add 1 plus 1 like this. This gives us a 3. All right, we do the same thing for 90. We're just going to substitute here a 90, which is going to give us 1. 180, which is going to give us a -1. We do the same thing for 270 in this case. That is 270, which is going to give us a +1. So with these points that we have, we are going to mark them and draw our graph, and also bearing in mind the shape of the graph that we are supposed to draw. We know this is the graph of a cos, and we are used to this graph to this graph of a cos. So whatever that you're going to draw or whatever that you must present also bearing in mind of the graph that you're going to have at the end. So if this is 0, you can just say this is 1, this is 2, this is 3, -1, -2, that's 90 degrees, 180 degrees, 270. Okay, so you just mark your points. The first one is 0 versus 3. 0 versus 3, you mark your point. 90 versus 1, that's 90 versus 1, you mark your point. 180 versus -1, so it's 180 versus -1. 270 versus 1, 270 versus 1, which is somewhere there. So we are going to mark the points, then we join our points now. This is supposed to be the graph of a cos. All right, we do not know exactly where it's going to pass, but it's just going to be something like this, a turning point, something like that, going to the other side. All right, so that was our graph of f of x, which is equal to 2 cos x plus 1 from 0 to 270. Where this is a turning point, this is going to be a solution. We don't know exactly the solution there that we're going to have, but it must be something that you must have at 120 there. It's 120 degrees, and somewhere just before at 240 degrees, somewhere there. All right, then this one is our turning point, which is at 180 versus -1. This is 180 degrees versus -1 like this. This is a turning point. And these are the solutions. It's not at 270. 270, it's this one versus 1. This one is not at 90. 90, it's this one versus 1 here on top. So the point there where it crosses the x-axis is the one that I'm referring to say that it's at 120 and the other one being at what? At 240, just before. All right, so you have to consider that. We can just consider that as part of our graph. And that was it. So this is it, guys, the paper that we wrote, a total of 100 marks. So you're just gonna try by all means to revise so that you'll be able to see if we are going to be advancing for our mathematics N4, or we are going to sit again for this level of N3. Whilst you are continuing with other subjects, you can do that, meaning to say the next trimester, you are going to be writing 4 subjects if you are like that. But if you know that this is actually fine, now it is the best time that you can just start to work on your mathematics N4, just the basics of your N4, so that when you are in that level, you are not going to have challenges in your mathematics N4. But as you can see, that was a fair question paper, I might say, but let me know about this question paper on our comment section. So let us know, guys, what do you think about the paper in terms of the weighing and the presentation of the paper on its own. Yeah, let us know so that we can be able to work on that.